Okay, so standard form. We're going to start with changing numbers into standard form and out of standard form, and then we're going to move into some operations, so adding, subtracting, multiplying, and dividing with numbers that are in standard form. When I give you practice questions, the practice that you most need as a class is the stuff where they are word problems to start with. Okay, but you can't attack the word problems unless these skills are in place. So let's start here with these skills. Going from an ordinary number to standard form when the number is a very large number. I'm talking about a number like that. A really big number, the sort of numbers that we use when we're measuring things in science, like the distances between planets, for example. Really big numbers. Or perhaps it's money that someone's making, or it's number of records that are sold. You know, really big numbers that people come up with in business or in science usually. So, first thing to remember about standard form is a number times 10 to the power of a number. This, at the start, has to be between 0 and 10. It has to be at least as big as 1. And it has to be up to, but not allowed to be 10. So, for example, 1.7, 9.8, but not 0.6, but not 12.3. It has to be between 1 and 10, but it can't be 10. Really important. The n up here is an integer. So a whole number, but it can be positive and it can be negative. Okay, so we have to have that in mind as a starting point. What we're looking at here is that this is going to become 2.705 times 10 to the power something. We know that because using these digits 27050000, it's the 2705 bit here that we need. If that's got to be between 1 and 10, then 2.705 is the best we can do. Now, you can simply count the number of places that the digits would need to move to make this true. From here, 1, 2, 3, 4, 5, 6, 7. This would need to, decimal point would need to look, because it doesn't move, but it would look like it had moved 7 places as the digits moved 7 places. Done. No bacon, lettuce, tomato sandwiches for those people after school. Wonderful. All right, so I know I'm here all week. So ordinary to standard form in small numbers. We're talking about things like this: 0.000009015. For example, so to write this in standard form, again, thinking about the A being between 1 and 10, we're going to need to use the 9 here. So it's going to be 9.015 times 10 to the power something. We know that it's going to be a negative power because for very, very, very small numbers, the power will be negative. Again, it's about how would it look like this decimal point has moved from here to there. 1, 2, 3, 4, 5 places that it has moved. So it's 9.015 to the power minus 5. Okay, it's about the number of positions the digits move, but we do it in a technique looking at how the decimal point has moved. Okay, from standard form as a starting point into ordinary numbers. Now, if it's a really large number, it might be something like 5.017 times 10 to the power 8. That means that decimal point needs to look like it's jumped 8 places in total. So it's going to go 1, 2, 3 places just to get past the 5017. 1, 2, 3 places. 3 out of the 8 places. How many more has it got to go? 5 more places. So I need 5 zeros here. And I can check then, would that work from here? 1, 2, 3, 4, 5, 6, 7, 8. It would. So 5, 0, 1, 7, 0, 0, 0, 0, 0. The great thing about standard form questions is, once you understand it, you can double check your answers really carefully, make sure you've got the right number of zeros in place. Now let's have a look at from standard form to ordinary numbers for really, really small numbers. So for example, 3.205 times 10 to the power minus 7. That means that that decimal point will look like it's moved 7 places to the left. So it's going to take 1 to jump over the 3. And then it needs another 6 things to jump over. So in this case, it's going to need another 6 zeros to jump over. 1, 2, 3, 4, 5, 6. And then I've got 3205. 3205. Before I commit this to final answer, let's check. If the decimal point looks like it's here, that's 1, 2, 3, 4, 5, 6, 7 places that it would look like the decimal point had moved. That's where the decimal point is. And of course, it needs a 0 in front, so it can become 0.00000003205. It's all about care and attention when it comes to these questions. When you get it and you know what you're doing, you just have to be super careful. Okay, if you're lucky enough to get a question like one of those 4, well done. You're more likely on a higher paper to get a question that looks something like these, where we're adding and subtracting and we're multiplying and dividing. So when you're adding and subtracting in standard form, you might get something like this. It might say to you, what is 5723000, and you might have to subtract something like 2.37 times 10 to the power 6. And if it asks you to do that subtraction on a non-calculator paper, what you need to do is convert these both into ordinary numbers. So for 237 times 10 to the power 6, 2 jumps to get over the 3 and the 7. So we're going to have 2, 3, 7, then 4 zeros. 1, 2, 3, 4. Double check that works. 1, 2, 3, 4, 5, 6. So it does. Now there is ordinary numbers. It's a case of subtracting. Now do your subtraction as if you were in primary school. We're going to use columns like you were very, very first taught. We're going to have 5, 7, 2, 3, 0, 0, 0, 0. And we're subtracting from that 2, 3, 7, 0, 0, 0, 0. Now, my advice is fill these numbers in here, starting at the back, so you get them lined up correctly. Now, there are 4 zeros here. 1, 2, 3, 4. And then it says 2, 3, 7. If you line it up like that when you're subtracting, everything's going to be okay. So what we need to do now is the subtraction. So 0 takes 0, 0 takes 0, 0 takes 0, 0 takes 0. 3 take away 7. We can't do that, so we have to borrow 1 from here. That makes 13. 13 take away 7 is 6. 1 take 3. We can't do that in this method, so let's make that 6. Make that 10 over here. 11 take 3. 8. 6 take 2. 4. 5 take 0. 5. 5, 4, 8, 6, 0, 0, 0, 0. It will expect you to write the answer in standard form. So this is going to become 5.486 times 10 to the power. Now let's be really careful. From here, 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. Now the last 2 minutes, we look at the last 2 questions, okay? Last 2 minutes, last 2 questions. So, multiplying in standard form and dividing in standard form. For multiplying in standard form, let's have a quick look at what this could look like. You might have something like 2.6 times 10 to the power 7 times 3 times 10 to the power 5. What you need to know for this is how to rewrite it. Take your A bits at the start, so we'll have 2.6 times 3, and then take your powers second, times 10 to the 7 times 10 to the 5. Then we can do the multiplications in two parts. 2.6 times 3, that's 7.8. 10 to the 7, 10 to the 5 becomes 10 to the power 12, and done. Dividing in standard form. You may have something like this. 4.8 times 10 to the 9 divided by 3 times 10 to the power 4. So, if you're going to do that, you need to rewrite your division, and you write it like this. You take the A parts first, 4.8 divided by 3, and then we do times 10 to the power 9 divided by 10 to the power 4. So you rewrite it in two parts, two separate divisions. 4.8 divided by 3 is 1.6. Using our index laws from earlier, 10 to the 9 divided by 10 to the 4 is 10 to the power 5. So not just changing from standard form to ordinary numbers and vice versa, not just for large and small numbers, but also the ability to add, subtract, multiply and divide. Remember, the questions they're most likely to ask you will be real life questions to do with usually science, but we'll have some practice on those questions in the future.